Hey everyone, so in this video we're going to be looking at example 2 from the assignment 18 notes on optimization word problems. So let's go ahead and get into it. A furniture manufacturer manufactures chairs and sofas. The steps in the production process are carpentry, finishing, and upholstery. Making a chair requires 6 hours of carpentry, 1 hour of finishing, and 2 hours of upholstery. Making a sofa takes 3 hours for carpentry, 1 hour for finishing, and 6 hours for upholstery. In one day, 96 hours of labor are available for carpentry, 18 hours for finishing, and 72 hours for upholstery. The profit per chair is $80 and the profit per sofa is $70. How many chairs and sofas should be made in a given day to maximize profit? Alright, so first things first, what are we solving for? Well, we want to know how many chairs and sofas should be made. Alright, so let X be the number of chairs, and let Y be the number of sofas. Now, again, it doesn't make sense to have -5 chairs made in a day, so we're just going to have X is greater than or equal to 0, and Y is greater than or equal to 0, making sure that they're both either 0 or positive numbers. Alright, part B, write the constraints for this problem. So this is where this example is a little bit less hand-holdy than the first one, because now instead of specifically saying what each constraint you're making, it just says write out all the constraints. So constraints are always things that you don't want to pass, right? Things that you don't want to go more than. So in our case, our constraints are going to be the 96 hours of labor for carpentry, the 18 hours for finishing, and the 72 hours for upholstery. All right, those are our constraints, because if that's all the labor they have available, then any more than that, they might have to pay overtime, or maybe they just don't have the people available. So those are the things that we can't pass up at all. All right, we have to stay under those. It's okay if we don't use all of it. That's perfectly fine, but we just can't go over. All right, so let's look at each of these individually. So first off, 96 hours for carpentry. So if this is hours for carpentry, we're just going to look where else does it say hours for carpentry. Well, chair takes 6 hours for carpentry. Sofa takes 3 hours for carpentry. So if we put all of those together, we're going to get 6 times the number of chairs, so 6x, plus 3 times the number of sofas, so y, is less than or equal to the 96. One down. So 18 hours for finishing. That one's going to be next. So that's hours for finishing. We got 1 hour of finishing here, 1 hour of finishing there. Alright. So a chair takes 1 hour, so it's going to be 1x, or just x, plus a sofa also takes 1 hour, so 1y, or just y, is less than or equal to 18. That's our second constraint. Our last constraint is that 72 hours for upholstery. So we know that chairs take 2 hours for upholstery, and then 6 hours for upholstery for the sofas. So it's 2 hours per chair, so 2x, plus 6 hours per sofa, so 6y, is less than or equal to 18. That's our second constraint. Our last constraint is that 72 hours for upholstery. So we know that chairs take 2 hours for upholstery, and then 6 hours for upholstery for the sofas. So it's 2 hours per chair, so 2x, plus 6 hours per sofa, so 6y, is less than or equal to the total, which was 72. All right, that's all of our constraints. Now we're going to write an equation for the profit. All right, so for the profit equation, I'm just going to put P for profit equals. We know it's going to be $80 per chair and $70 per sofa, right? So it's 80 per chair, which was X, plus 70 per sofa, which is Y. All right, now we're ready to do a bunch of graphing. All right, so first off, don't remember that the X and Y axis are both, let's see if I can do it to where y'all can see it. These are both constraints. So I am just going to go ahead and kind of highlight those just so you don't forget. Those are constraints. Our shaded region in the end can only be up in this quadrant. Can't be anywhere else. Okay. Now, off to the side, I'm going to start solving for y in these. So the first one is 6x plus 3y is less than or equal to 96. All right, so if we solve for y, we're going to subtract 3x from both sides. Get 3y is less than or equal to negative 6x plus 96. And then divide both sides by 3. Get y is less than or equal to negative 2x plus 32. All right, now here's the problem. Our graph does not go up to 32. Only goes up to 24. All right. So there's a couple of things that we could do. First off, we could just change the scale of our graph, but I don't really feel like changing 24 numbers and then having to worry later about it being way smaller of a scale since the numbers are going to be doubled. So if we had some starting point, then we could graph this, right? That's what the y-intercept is for. It's like a starting point for you to graph it with slope after that. Well, if the y-intercept doesn't work, maybe the x-intercept will. All right, so to find the x-intercept, all we're going to do is set y to 0, change the inequality to just equals, and the rest stays the same. Now we're going to solve for x. So if we add 2x to both sides, we get 2x equals 32. Divide both sides by 2, and we get x equals 16. So that means 16, 0 is a point on our graph. So 16, 0 is right here. And then remember, our slope was negative 2. So that usually means down 2 over 1. But we can also just do the opposite of that. We can go up 2, left 1. That way we can just travel up and to the left instead of down and to the right off the graph. All right, so I'm just going to keep going up 2, left 1 until I run out of space. All right. Now I'm going to draw the line through these. There we go, there's our line. And notice that it doesn't quite ever touch the y-axis because we don't go up that far. That's perfectly fine. For our purposes, it's not going to make any difference, and you'll see why in a second. All right, so we do have 2 more lines to graph though. So let's go ahead and get started on graphing those. All right, so just down here, I'm going to do our next one, which was x plus y less than or equal to 18. If we subtract x from both sides, we get y is less than or equal to negative x plus 18. So this one's on our graph. We just go up to 18, put our first point. Then we go down one, right one for our slope. And again, I'm not just going to stop by doing it once. I'm going to keep going down one, right one, over and over and over until I run out of room. For this reason right here, see how easy it is to tell that those overlap there because I put both dots on top of each other? It's going to come in handy in a second. So now we draw the line through it, put our arrows, and only one more to graph now. Alright, starting to run out of room down there, so I'm just going to go back up here to where we actually had this. So if we subtracted 2x from both sides, we get 6y is less than or equal to negative 2x plus 72. Divide both sides by 6. We get y is less than or equal to negative 1/3 x plus 12. Again, luckily this is one that is on our graph. So it's going to be at 12. Then we go down 1 over 3. Again, I'm just going to keep repeating this until I run out of space to do so, which is right there. Draw a line through it. Put our arrows. And now it's time to shade. Alright. So remember, all of these were less than or equal to. If all of them are less than or equal to, you just shade in the corner. So that's what we're going to do. We're just going to shade down here in the corner. There we go. Alright. Now again, just to make it easier in a second, I'm going to go ahead and just kind of outline where our shaded region is. That way we can easily tell when we're looking for corner points. Alright, so part E. To find the optimal solution you are looking for, you're looking for the maximum. Use your corner points to find the maximum profit. So what are all of our corner points? We have 0, 0. We have 0, 12. We have 9, 9. We have 14, 4. And lastly, we have 16, 0. Now, we're going to need to put these inside a table again. So I'm just going to go off to the side. We need our point. And then we need what we're plugging our point into, which remember, we already got that. That's the profit equation up here. So it's the 80x plus 70y. Alright, so if I put all my points down here, we're just going to plug them into the 80x plus 70y. That's going to get us our profit. So it's going to be 0, 0, 0, 12, 9, 9, 14, 4, 16, 0. Start plugging these in. So 80 times 0 plus 70 times 0 is just 0. First one's easy. For the next one, it's going to be 80 times 0 plus 70 times 12. And again, you can just plug these into your calculator. This one's going to get us 840. 9 nines, we have 80 times 9 plus 70 times 9. Plug that in your calculator, you should get 1350. 14 comma 4, so 80 times 14 plus 70 times 4. Put that in your calculator, you should get 1400. And lastly, 80 times 16 plus 70 times 0 will get you 1280. So what is our maximum? It's going to be this row right here, because the 1400 is the biggest one. All right, so when it says find the optimal solution, the max profit and the amount of chairs and sofas it takes to get it, that just means we're going to have to write it kind of like this. We have a max of $1,400. All right, with 14 chairs, because remember this is just X and Y, so chairs was X, so 14 chairs and 4 sofas. And that's our answer. So we can make $1,400 profit by making 14 chairs, 4 sofas. That's our maximum. All right, we have one more. So there's one more video for y'all to watch. It'll be example 3. And I will see y'all in that video.